Hi everyone, my name's Elliot Dessi, I'm ADEY's National Training Manager. I'm really excited to be here today live at the ADEY Lab in Sittingbourne with Josh, our Head of Chemistry. Josh, how are we today?
I'm fine, thank you, mate.
Good. And Josh, can you just share a little bit about what you do at ADEY? What is it like being Head of Chemistry?
Yeah, sure. So, as being Head of Chemistry, I head up both the chemistry testing services in terms of water samples and the chemical R&D lab in terms of our formulations.
Fantastic. Great stuff. Well, I've had a really enjoyable day today, sort of having a tour around. Really interesting stuff going on here, Josh. And I think from a heating engineer's perspective, you may have seen the ADEY water test kits on the shelf, the domestic ones that you often see in the merchants. And I guess, Josh, for me, it's just getting that understanding of what exactly do we do here? Because, you know, what are we testing for? When you send a sample to the lab, where does it go? What kind of things are we picking up on? And I guess just having that deep dive into water quality, because as heating engineers, probably all of you have experienced water quality related breakdowns, you know, sludge problems, all sorts of issues that you can get from bad water quality. So let's have a look at this, Josh, because we've got some really interesting stuff here, and I think I'd like you to just sort of share what exactly this means and what we're looking at.
So when the water samples come in, we are looking for both the non-metallic components and the metallic components, along with the solid components of the sample. So what we have here are a variety of live samples that have come in with varying amounts of solids and the type of solids that were in them. So by performing this test, we can quickly see how much solid is in the system, along with what type of solid it is, and then we can prescribe a good solution to overcome that.
Yeah.
For example, both these papers here were from samples that contained quite a lot of iron corrosion, as you can see.
Yeah.
However, one is black and one is orange, yet they've both got iron corrosion. So what that means is this system, along with having iron corrosion, was also suffering from a lot of air ingress problems. A lot of fresh water has been added.
Yeah.
And this one is a sealed system, because when left to its own devices, the iron corrosion will preferentially be in this state, which is the Fe2O3, as opposed to the Fe3O4, which is the characteristic magnetite.
Right, yeah, because I guess, really that's what you see on a magnocline, isn't it? What's captured on the magnet, and I think it's an interesting one. So really then, if there's anyone cool that has, you know, that job where you're not quite sure what's going on with the water quality, there's a lot of rust, you're not quite sure the best way of treating it, really, that sending a sample here will give you that full analysis, and you guys can give a recommendation of exactly what you think we should do to resolve the issue.
Yeah, definitely, yeah.
Fantastic, okay. And what's this one here, Josh? This kind of green
So this
sample?
one here is an example, again, of a system that had higher level of corrosion, but this time it was copper.
Right, okay.
It's that characteristic green colour.
Yeah.
So in this situation, we can then prescribe that you need a cartridge filter instead of just simply a magnet. Because as we know, copper is not magnetic.
Sure.
The same way rust is not magnetic.
So that's when you're in kind of cold flush territory, getting the water out, etc.
But crucially, by doing this test, we can therefore actually prescribe a direct solution for that individual system's problem.
Fantastic. Okay. And that's something that happens on all of our domestic testing when you send a sample
This
through?
is the commercial testing.
Yeah, okay.
Yeah. But we do a lot of testing on the domestic for metallic corrosion.
Fab. Okay. So just next then, so we've got here, this is interesting, this is. So we've got two containers, one with MC1 plus inhibitor on the right, one without on the left, which I must say, this was only done a couple of hours ago. And what I found very interesting is, I guess you could explain, Josh, we've got several different metals there, haven't we, spinning around in the water. And I guess, could we just explain to everyone, what are those metals and why?
Sure.
You know, what are we trying to do here?
So with these coupons are representing the metals that you would commonly find in a central heating system. Not only are they the type of metal, they're exactly the grade of metal that you would find. So we've got aluminium for heat exchangers, we've got copper for pipe work, mild steel for radiators, stainless steel, which can be used for heat exchangers also, brass for any fittings, and then a second coupon for mild steel.
Wow.
As we said, these were set up just a couple of hours ago, and as you can see, the one that has not got any MC1 Plus inside has already started to show signs of corrosion, and
Yeah.
the fluid itself has started to go tinted with the characteristic iron colour.
So I guess the question I've got really is you know, I would always use inhibitor.
Yes.
But I'll be honest, you know, I know that, you know, BS 7593 states that inhibitors should be tested for annually, and obviously it's something that boiler manufacturers will check for when they're doing a warranty call. So we know it's a really good way of helping prevent this corrosion, as we can clearly see already. I guess a question for you, Josh, is how exactly is it doing it? So I appreciate that I can see it with my eyes, but what's actually happening there? When we put an inhibitor in, what does MC1 Plus do?
So MC1 Plus contains quite a few ingredients that will inhibit the corrosion of the metals. So one aspect, and a very simple one, is that it keeps the system water buffered at a neutral pH.
Okay.
Because if the system water goes acidic, then you're going to start to get corrosion of any iron-based components.
Yeah.
If it goes alkaline, then you're going to get corrosion of any aluminium-based components. Aluminium will also corrode in the acidic conditions as well, but aluminium particularly will corrode in both acidic and alkaline conditions because it's known as what we call amphoteric.
Right.
So if you've got an aluminium heat exchanger, then you really need to be on top of your water quality and keeping the pH buffered at a neutral value. Secondly, it contains form-filming ingredients, which then coat the inside of all the surfaces of the system, and again, this aids in the inhibition of the corrosion.
Wow. Okay. So it's a lot going on really. When you think about it, it's not just it's several things like you said. It's pH. It's and I guess touching on aluminium, that's something now we see not just in heat exchangers, but obviously a lot of radiators now. A lot of designer radiators tend to be aluminium. So it's surprising really how much aluminium you probably would find on an average heating system now.
Yes.
So,
Yes.
Okay, fab. So let's have a little look at the, you mentioned about some of the domestic testing and how you've kind of got separate tests. One's detecting your kind of your metallics and your metals and one's not. Should we have a look at the first one and see what's...
Sure. So let's have a look at the non-metals first.
Okay.
So as you would have seen in the merchants, these are the ADEY water testing kits. They come in the merchants, they come with a pre-postage bag. You can simply take a water sample from the mains and the system. You can pop it into the prepaid bag, put it in the post, and then it will come to us the next day as it's a first class envelope. When the samples arrive here in the mornings, they're unpacked, they're sorted, and then we start to analyse them. Firstly, we are analysing for the non-metals, so the pH, the conductivity, the hardness, and the chloride level. These are very important analyses because if the pH, like I said, is too acidic or too alkaline, then you're going to start to get corrosion issues.
Yeah.
High levels of chloride will also give you tremendous problems with any iron-based components. So when we have the samples, we only need 5 millilitres of sample, and the way that we can do that is the samples are poured into these little cups, and these are then barcoded. So each sample will have its own unique barcode. That's crucial for our UCAS accreditation to have traceability of all the samples. Each sample is then peeled off and labelled onto the worksheets. Once that's happened, the analyst can then load the rack into the instrument, and then what happens then is the sample is analysed for the analytes that we've requested. How that happens is a very small proportion of the sample is aspirated up and placed into these cuvettes. And if you can see quite clearly, there's a little clear section on the bottom. Those little wells are where the analysis takes place. So each well will be one sample and one test. So sample 1 hardness, sample 1 chloride, sample 2, and so on. And then what happens there is the sample is added, the instrument is then blanked as a start point, reagent is then added, and then what happens is there will be a chemical reaction inside, and then it is remeasured, and the amount of light that is now absorbed based on the light that was absorbed at the start, the increase in the absorbance is the amount of the analyte that you're looking to analyse, for example hardness or chloride. And this will quite happily work away, automated, well over 150 samples a day, and we've got more than one instrument, which that's what allows us to do the rapid speed of service. It allows us to get all the samples tested in the same day that we receive them through having high levels of automated equipment.
That's fantastic. I mean, it's a great bit of equipment. I think some of the installers on the call, Josh, will be familiar with the ProCheck test we do, like our on-site water test.
Yes.
Obviously, what I'm interested in, this is obviously a very in-depth test, basically, in total. I'd be interested to know kind of what are the parameters we're looking at here, because I can see it's obviously...
So here's an example of a domestic water test report, and with the ProCheck, we are looking for adherence, the corrosion, and the inhibitor level, and the pH. This will then break down the corrosion to each metal type. It will also allow you to detect for not only inhibitor, but whether or not ADEY MC1 Plus has been used or not. That's crucial for any specified jobs.
Yeah.
It will also give you a breakdown of other items that are not included in the ProCheck. For example, the hardness of the water, the chloride, and the conductivity. And those aspects are very crucial because hardness, for example, if the hardness has dropped dramatically from what the mains hardness was, then the question is, where has the hardness gone?
Yeah.
And the answer to that is it's formed scale on heat exchanger surfaces and other areas that are hot inside the system. So by ascertaining the hardness of the system, you can then also report back to the customer if there's any issues with scaling. Is the heat exchanger going to need any work doing to it in the future? So there's quite a lot of parameters that takes the ProCheck further.
So really, for anyone looking for that deep analysis of the system, this really is going to give them every single element they could ever need, essentially. So great. So commercial testing.
Sure.
Let's have a look.
Sure. So again, this is something that you may have seen in the merchants. It is the ADEY System Diagnostic Test Kit. This is more suited to the larger commercial systems that we find. It works off of the same principle that you can take the samples, you pop it into the prepaid post bag, that's included, we then get it, and then it's analysed. However, this one, due to there being more analytes involved and some more time taken, this one is analysed and sent back to the customer after 3 working days from when we receive it. Furthermore, this offers more analytes than is available on the domestic kit to allow that further in-depth analysis of the larger commercial systems, which includes the solids analysis we saw at the start. So with this one, where we can look at the level of the suspended solids, we look at then all the metal types, so aluminium, copper, iron, zinc. Both types of inhibitor you normally find in the commercial world. So in the domestic market, molybdate is the main source of corrosion inhibitor. In the commercial world, a lot of people use either sodium nitrite and sodium molybdate mixes, or just sodium nitrite.
Interesting stuff.
Yeah.
Okay, and I can see next to it we've got MC35 commercial non-drain cleaner. So obviously this is one of our cleaners that is suitable just for commercial systems, Josh. But can you just talk a bit about that? Because obviously a non-drain cleaner, that's something different, right?
Yes. So with the non-drain cleaner, it has both a mix of cleaner and corrosion inhibitor in the same formulation. It also contains additives that allow for any solids that are in the system to be carried away, to distribute, like removed from where they're sitting and carried away in the system flow to the filter. And that's quite crucial. If you're looking to put MC35 into a commercial system, then you'll definitely need to have a filter fitted. This is due to when this lifts any particulate debris matter that's in there, and that will be carried along. It has to go somewhere, and if there's no filter fitted, then that will go straight to the heat exchanger and cause blockages. Yeah,
it's interesting stuff. And we did have, well, while we're on cleaners, actually, Josh, we did have a question come in regarding our standard. This is going back to sort of domestic systems now, but our standard MC3 Plus and our MC5 cleaner. And we had a question from somebody that was asking, what what is the difference between the two, and you know, when would you recommend one over the other?
So the difference between MC3 Plus and MC5, there's a slightly different chemical balance inside. The MC5 is a cleaner that's more suited to a heavily sludged up system versus the MC3. Being slightly stronger, the MC5 can only be left in the system for up to 7 days,
Okay, yeah.
whereas the MC35 can be left for up to 28 days. Both are great cleaners, but if you're looking to do a system flush on the same day, then the MC5 is the more suitable cleaner, as that gets to work a lot quicker than the MC3 due to the slightly different formulation of the product.
Okay, fantastic.
It works great with the Magna Cleanse, so you can get in, get it flushed, and get it cleaned and refilled in the same day.
Yeah, okay, fab. So yeah, interesting. I think let's have a little look at the sort of metallics testing that you were talking about as well. I think that links quite nicely to what we're talking about really, because I found this really interesting earlier today of exactly what this is, because this looks like some pretty advanced kit to me.
Sure. So this is what's called an ICP, which stands for inductively coupled plasma, and this is the optical emission type. What it is doing here is we are looking for the metal component of the sample.
Yeah.
We could analyse for most of the periodic table, but we've currently got it set up for the elements of interest. So iron for radiators, things like copper for pipework, zinc because you can alloy to make brass, aluminium for heat exchanger material or radiators. Some people still use borate and molybdate as a key component of corrosion inhibitors. And what's happening here is the samples are being aspirated up. So this is actually working away right now on live samples.
Wow.
Yeah. So the sample is then aspirated up and goes through what's called the spray chamber.
I found that really interesting because it's almost like a mist, isn't it?
Yeah. So inside the spray chamber, a little hurricane happens basically, and all of the larger droplets are thrown to the outside and then taken away to waste, leaving you just with a fine mist that is going up, as you can see here.
Yeah.
That goes up into the plasma flame. So inside the box there is the argon plasma flame. That's ionized argon gas. And the tip of the flame there is around 10,000 degrees. So it's like the surface of the sun inside the box.
Wow.
Yeah, it's quite hot.
It's pretty hot.
Yeah, it's warm. So what happens then is when the sample goes up, though any atoms of metal that are in the sample are then bombarded with all the energy from the plasma flame. And we've all seen that classic picture at school of the atom with the center nucleus, and the electrons go around the outside. When they get hit with all that energy, the electrons then move to a higher orbit. When they come back down, all the energy which they gain, they send back out in the form of light. We know that white light is a mixture of all the colours of the rainbow, and what that means is all the colours of the rainbow are slightly different wavelengths of light. So when the atoms send out that light, that is characteristic just of the wavelength that is characteristic of one element, the instrument can then see which light waves are coming out, along with how much of it's coming out, to see which metal's in there and how much of it's in there. Because each metal emits light, characteristic wavelength that only it will have.
Wow. Fantastic.
And we've got a second instrument to again allow us to have that high capacity throughput, that speed of service that our customers are expecting.
It doesn't look like cheap equipment either, Josh, to me.
No, it's certainly not cheap equipment. that is for sure.
Premium stuff. It's
it is.
Wow. So there you go, guys. It gives you a really, great insight into what happens when you send a sample, and actually the quality that's being delivered here is phenomenal, to be honest. I guess another thing I wanted to speak to you about, Josh, was MC1 Plus inhibitor.
Yes.
Okay. So we mentioned that it's performance tested.
It is.
Okay. I've heard a little bit about sort of NSF, ratings and approvals and so on. And I'm just really interested to sort of know when you performance test MC1 Plus.
Yes.
What are you doing exactly? What test are we doing? And how can we sort of confirm that it's always, you know, good?
So the NSF testing comprises of 3 parts. So the first part is the performance of the corrosion inhibition. The second part is the inhibition of scale formation, and the third part is how the chemical will interact with any rubber components, i.e. O-rings, gaskets, etc. When we batch test it, we batch test every batch of MC1 Plus here at the lab for the corrosion performance testing. We then can see and ascertain how each batch will perform in a corrosion environment. We can then ascertain if the product has changed through batches. We can then keep our batch control quite tight. We can trend the data over time and to see how batches are varying over time. When you go for the NSF accreditation, that lasts for 5 years, and you have to resubmit your product for testing, either to a accredited lab or to an independent lab, which then will send the results on to NSF for further review. That lasts for 5 years, and you must do it once every 5 years, or if you reformulate your product, because then you're not selling what you originally tested.
Okay, yeah.
However, we don't do it once every 5 years. We do it on every batch, which works out to being about 1 a week.
Wow.
Every week, continuously, and have ever done.
So it's really setting that bar of consistent, consistent product. It's
Yes.
always going to deliver what it says.
Mm-hmm.
You always get the performance we're describing.
Yes.
It's always going to give you the correct treatment in litres to what it says on the bottle. So
Yeah, and every batch of MC1 Plus, as we said, gets sent here for testing, and it is not sold until we've actually completed that test. Then we know categorically that will work, and will do exactly what we said it should do,
Yeah.
and then it is actually sold. So every bottle that is ever out there can be traced back to an NSF test here, and we can track back to who tested it, when, was all the equipment calibrated and in date for every single test going back about 10 years.
it's fantastic.
Yeah.
I wish I was that organised.
Well, that's part and parcel of being in a lab.
That's great. That is really interesting stuff. To be fair, it's it's just great to know that you've got that kind of consistency every time, isn't it? Really.
It's also key to mention that we've had this contains a lot of investment in this product.
Yeah.
Lab equipment, as we briefly touched on, isn't cheap.
Yeah.
We're talking 6 figures for most of the large items here.
Yeah.
So vast amounts of investment's gone into this lab, but then it ensures that the quality of the product we're selling and the samples we're analysing, customers can then have those results with assurance that they are spot on.
Yeah, that's brilliant. And I guess one thing as well that I've heard a bit about is the fact that you mentioned UCAS,
Yes.
and obviously we are a UCAS accredited lab, and
Yes.
correct me if I'm wrong, Josh, but we're the only UCAS accredited lab that can actually carry out this performance testing of inhibitors as per NSF's
Yes, we are.
requirements.
Yes.
So that's a great, great
Yeah, that
great
makes
thing to
us
have, really.
that makes us one of a kind, really.
Yeah.
To be the only UCAS accredited lab for the NSF testing is quite something special, really.
Fantastic stuff.
And we are a UCAS accredited lab for all of the other water testing here, which again ensures full traceability of all the samples down to the analyst who performed it, when, and all the chemical reagents that have gone into that testing. Were they in date? When were they last calibrated? When were they last checked? There's a lot that goes on behind the scenes to obtain that UCAS accreditation and then to keep that UCAS accreditation, but then it ensures the quality and reliability of the final results.
Yeah, no, fantastic. And I guess obviously over here we've got some final bit of equipment here, Josh. So what's this exactly?
So this is an ion chromatography machine. This is where we're looking for what we call anions.
Okay.
So which are a lot of the anions that are based this end of the periodic table.
Yeah.
So we're looking for things like fluoride, chloride. We can look for phosphates, sulfates, nitrates and nitrites. A lot of the stuff on that side of the periodic table, because they are all minus. They're all minus ions. They're all negatively charged.
Yeah.
And what happens here is with chromatography, it's simply the splitting up of a sample into its constituent parts. So, for example, we have a continuously flowing stream of eluent, and then the sample is injected into that flowing stream.
Okay.
As it moves through the separation column here, all of the anions will travel through the column at varying speeds. Some come off really quickly, some travel quite slowly. And what happens is the instrument is constantly monitoring the conductivity of the background flow in the eluent. And when all of the same anion group together and then come off the column, there's a sudden spike in the conductivity when they come off. For example, when the background flows through and then there's a sudden spike, that's fluoride, and then back down again. And then there's nothing for a while, and then there's a big spike, and then that's chloride, and down again, and then nitrite, and so on. And what happens is, as this constantly flowing eluent progresses, all of the anions are coming off at slightly different times. And that's all it is. It's just the separation of different constituent parts of a sample. That's what chromatography is. Everyone would have done that. Again, the classic experiment at school with the paper and the ink dot and the water goes up the paper,
yep,
and the ink dot separates that into all of the colours that ink was made of. That's all chromatography is. It's just the splitting up of something into its constituent parts.
Fantastic.
And there's different ways of doing it. There's liquid chromatography, there's gas chromatography, there's paper chromatography. There's different ways. But this one is the ion chromatography, which are looking for the anions of interest in closed loop systems.
I mean, what I found really interesting earlier, Josh, we were talking about dissolved metals in water.
Yes.
And how if you've got dissolved metals, it's essentially become part of that water at that point.
Yes, it has.
And I don't know if you want to just share. You put a really good point earlier about kind of sand in water versus sugar in water. I thought it was a really good way of putting it.
So
for me to understand
yeah, sure.
What you.
So when we're talking about metals that are in the water dissolved, we're talking about they are no longer in the water as solid particulate matter.
Yep.
They have, like you said, they have become part of the water. A common analogy to translate that back would be if you had 2 cups of water and you placed sugar in one cup and sand in the other, mix them up. The sugar will dissolve and become part of the water. You can't just filter it out. Whereas the sand will stay as a particulate matter, which you can then pass through a filter and actually remove those solids.
Yeah.
So that's a crucial distinction, is when something is dissolved in the water, it becomes part of the water. And the only way to then remove that is to remove the water, because you cannot skim it out.
And I guess really that's when, from a kind of remedial work perspective, that's the difference between, cold flushing the system and getting the water out, and actually using the magnet cleanse process to extract the magnetite, because there are particles there to extract. And I think that was it really kind of struck me, that did, is a really good way of putting it.
Yeah, and it really is true, because if the particulates are no longer existing as particulate, then you can't get, they're in the water physically, and you can't see them, they're in the water, and you can't just filter them out, either through magnetic filtration or through cartridge filtration. And
I guess one thing I want to touch on as well is the fact that obviously it's quite evident here that the chemicals that are being tested and to the standard is phenomenal. It's a fantastic facility. So obviously we can vouch for the quality of the chemicals, but I guess what I find interesting is actually how our chemicals can work in conjunction of one another. So it's not just that we've made good individual chemicals, but you've actually thought about how I mean, a good example would be MC3 or MC5 cleaner. And if you put a cleaner into the system, you can actually use MC1 plus inhibitor, and that will neutralize up to 20% of remaining cleaner. So I know, from a flushing perspective, it's always crucial that we get the cleaner out of the system, and we do everything we can to achieve that. But I guess from that kind of extra buffer and peace of mind, Josh, to know that if you follow up with this product, you've got that little bit of protection there, haven't you?
Absolutely. So, as you said, if you do use the chemical cleaners to clean a system, and you flush it out, or there's a hard to reach area that you just can't get out, or you may even forget to do one leg or one radiator, or even if there is a dead leg, then what happens is when you add the MC1 Plus inside, it has the capacity to neutralize any remaining cleaner that's in there, so you won't pose any problems ongoing with the cleaner residues in there, which is quite crucial to ensure that even if you can't get it all out and you add MC1 plus afterwards, then the system will still be fine.
Yeah.
And as we said, these all work in conjunction. So the cleaner will be good for cleaning a system. This will neutralize some of this one. But crucially, you can use MC10 plus and MC1 plus together in underfloor heating systems. So systems that are running at a lower temperature, i.e. underfloor heating systems, or with the advent of Part L recently, with a change in the flow temperatures.
Yeah.
We're seeing that biocide is becoming more and more of an essential chemical that is needed to be added into systems.
And I guess you referenced Part L there, Josh, and you reference obviously lower temperatures. So many of you on the call will know this, but if you don't, the details basically is that any heating system now going in, regardless of its fuel type, so if it's a heat pump or if it's a gas boiler, if it's a full heating system, as in new rads as well, underfloor heating, new pipework, so we're putting a system in from scratch, we should be, where possible, designing heating systems to run no hotter than 55 degrees. So I appreciate not in all cases you can achieve that, obviously depending on the installation of the property, but ultimately, you know, it's trying to do the best job you can to run the system at a lower flow temperature to help with efficiency. And I guess you mentioned biocide. I think it's just important really to touch on what exactly is it for. So you've mentioned lower temperature. Why do we need biocide? Why is it part of BS 7593 now?
So when you're running your central heating system at a lower temperature, or with underfloor heating in particular, you've got water that's not getting hot enough to self-pasteurize or to self-clean itself. So what happens is the water will start to have bacteria growing in it and other growths like algae, for example, and other bacterial forms. As we've known for centuries as being people and human beings, water doesn't store well. Left to its own devices, water never stores well. Yeah. Any water that is considered to be not flowing or any water that is stagnant, you just know it's not going to end well.
I guess think like hot tubs. You've got to put chemicals in. You've got to put you've got to test for pH, haven't you? You've got to kind of keep on top of the water, don't you? So I guess if you're not doing that, you lift the lid up. Come summer, it's been closed, or winter, and you've got film all over the top of it. That's really what you're referring to, I guess.
Absolutely. So in terms of the biocide, especially for the underfloor heating systems, you get bacterial growth and biofilms that are building up inside on the pipework. And when you've got the underfloor running at a low temperature, you know, in the 20s, you only need a few millimeters of biocide or biofilm growth. Yeah. And that will quickly impede the heat transfer of the water into the floor. And because you're only starting in the mid-20s to start with, a couple of degrees off from where you set it is quite a big percentage. If you set it at 25, but you're only getting 22 or 21 out of it, that's a big proportion of the heat that's been lost through not much biofilm growth. And by adding the MC10 plus biocide, it will prevent the growth of these biofilms and bacteria. And the biocide itself is specially formulated for closed loop systems, and it contains more than one active ingredient. So it is very good at being specifically targeting for closed loop systems and bacteria that you'll find in closed loop systems.
Fantastic. Okay. Well, guys, I hope you've enjoyed our tour this evening. I really appreciate you spending a bit of time and listening to Josh talk about this. It's really interesting stuff. So I think next time you're in the merchant, keep an eye out for an ADEY water test and biocide. If you haven't seen that before, obviously it's different product now. And Josh, any last points?
Well, I mean, it's been great to do this tonight, and and really good.
Cool. Thanks, guys. We'll see you again.
Bye bye.